Ryan Oates talking about Docker. Yes. Hello, and I'm going to move this back a little bit because I don't want it right in my face.
I want to be able to see online.
What?
Yeah, that's why I moved it there.
Oh, okay. Well, I guess I will stand in front of...
It's obtrusive, but it's not that big.
Okay. Okay. So, today we're going to talk about Docker and using it as a development tool, not so much as an orchestration layer in production. You totally can do that, but this is more about developers and improving our workflow. A quick aside, anybody know what this whale's name is? Anybody? Okay, his name is Moby Doc. Yeah, yeah, it's cringe. My name's Ryan Olds. I'm a lead software engineer at Envision. I just telecommute. They got a distributed workforce all over the world. I work with people in the Czech Republic and Brazil and San Diego and Israel and all over the place. And you can reach me at my email address, and all my code is on GitHub for now. If you have any questions, just raise your hand. That includes comments. If you just are like, hey, I don't understand, or hey, there's a really important thing that helped me on this particular portion that you're talking about, raise your hand. I'll call on you. There's also going to be questions at the end, so you can also hold them if you want. And these slides and the code can be found at these URLs. Okay, so today we're going to be talking about the pain points around maintaining maintaining, updating, setting up, adding new services to our development environments. We're going to talk about just containers and virtual machines in general. We're just going to touch on that because it helps kind of understand what Docker is doing. And then we'll talk about Docker itself, the Docker engine, and then we'll talk about Docker Compose, which is a super amazing, useful tool. And so when we talk about pain points around our development processes, I don't know about you guys, but the environment I'm working in, there's dozens of microservices, and there's just tons of people shipping code constantly. And so keeping our local development environments up and kind of up to date with what's in production or with at least what's on test would be an awful, awful ordeal if we didn't have Docker or some kind of container service. We would be checking out a dozen repos, 24 repos, going into each repository, polling and building and doing all these extra steps. And what we're going to find is that Docker and other container services make a lot of that much, much easier. And that's kind of what we'll be covering. The skill set required to use Docker versus maintaining virtual machines or even maintaining just a local environment where you're, again, maintaining 24 repositories and setting up databases and migrations and dealing with all the normal maintenance stuff around maintaining your application service as well as all those supporting services. The skill set required to do that, you almost have to be a sysadmin. And that's not something that most developers aren't sysadmins. Some people are, and they're in that DevOps group, and they can do it. But do we want everybody to be DevOps people? And then onboarding new developers can be a huge pain if you have a giant amount of services, or even just a small amount of services, like one application service, and maybe you have Postgres or MySQL. And maybe you have RabbitMQ or something like that. Just onboarding a new developer, you end up with a giant doc. And they're having to spend 2, 3, 4 days just working through that doc and finding all the little things that didn't get documented. It's just a big pain onboarding people, and Docker and containers can really, really simplify that and turn them into one-liners. One key thing we have to Docker and containers help with both microservices and monolithic applications. They'll help with microservices more because you're saving a lot more time with all those extra services. They still help with monolithic applications, just not quite as much. You still get some benefit. And then, as I kind of touched on earlier, the routine maintenance around maintaining our development environments it can be a lot of time. Docker will help with that. As I touched on the skill set already, this slide's kind of duplicate, but, and then if you're using, some teams just even completely forego having a local development environment, and they'll have you work on a shared environment. And then you end up like anytime someone ships bad code or breaks something, everybody's no longer working. And so if you're in like that kind of environment and you're worried about, well, if we have all the developers run their own local environment, it's just going to be so much work to keep that all up to date. With Docker, you can kind of avoid all that. You can keep everyone up to date and reasonably in sync without a ton of work. Oh, I totally skipped the question because I'm not really reading my notes. How many here have used Docker? How many here have heard of Docker? How many here use virtual machines? So just for the people, you know, at home, way more people raised their hand on virtual machines than even had heard of Docker, and maybe about 5 people raised their hand about using Docker. And so the key thing to understand with containers and virtual machines, which most people seem to be more comfortable with, is it's really about where the operating system is. So when we look at containers, whether it's Docker or any other container environment, you don't have all these guest OSs. Your containers and the engine are running right on top of the host operating system in a jailed environment. And all these containers kind of share the same network stack and storage stack. Whereas with the virtual machines, you have all these guest OSs, and they're running on top of a hypervisor or another operating system. And there's kind of a debate about which one should you use. And it really just comes down to, do you need the extra isolation offered by virtual machines? Question. So my understanding is that Docker uses LXC. And then there's LXD, which is like virtual machines, like as more of a...
So Docker uses libcontainer, and LXC is a separate library.
Oh, is it? Okay, okay. And yeah, so yes, there are other options. I know some people are super excited about LXD, which is, I think, a little, it's almost a high, I don't quite, I'm not super familiar with it. It's a little bit of a hybrid.
It's system containers.
Okay, and it's like System D, which is what I understand the D being from, but no, not at all. It's not like running off a System D, and it's...
No.
Okay. You know more than I do about this. That's totally fine, and that's why you're allowed to raise your hand during... So, any questions here? Does this kind of make sense? Like, the difference is to, you're running guest OSs with like completely duplicated environments and their own kernel and everything. And then with containers, you're pretty much running on top of the same kernel, with an exception that I will get to in a moment. You're pretty much running on top of your host operating system's kernel, but in a jailed environment. Any questions? Cool. Oh, Colin.
Those two sides would look more like each other if the guest OSs weren't so tall.
Yeah. What's funny is the Docker container isn't even that thick, I think. So like we could make it super thick, but I don't think it's that overweight. Okay, so Docker containers is one implementation of containers. There's other solutions like Kubernetes. I find that they're more popular kind of on the production operations side. Like they're much better at like scaling out large infrastructures, and they're a little heavyweight for like a development environment. And then one key thing to note with like Docker containers is all the containers on that host OS are kind of sharing the same network stack and a lot of the same storage, which is one of kind of those trade-offs between virtual machines or even this third approach where you have a bit more isolation with virtual machines. So if you're running in an environment that's like super worried about security and worried about like maybe one of these containers somehow starts making, like breaches the jail that it's in, you might want to run virtual machines in that case. The attack surface is a little smaller. Installing, super straightforward. It runs on all the major operating systems. It's pretty much just download it if you're on Windows or Mac and run it. If you're on Linux, it's like apt-get or yum install. One funny note is that on Windows and Mac OS, it's running inside of a virtual machine. So you're pretty much running a virtual machine so that you can run Docker engine inside of it and then run containers on top of that. It's rather funny. It works okay. I don't have any complaints about it. If you're on Windows 10 and you want to use the bash, the new bash feature, which I would encourage you to use, it actually works okay for a Microsoft product. And I say that as someone that likes Apple even less than Windows, or Mac OS even less. So there's additional steps to get that Docker command line utility working with the Docker, the Windows version of the Docker engine. And so we're going to kind of go through setting up a very small, stupidly simple Node.js application. All it does is it listens for requests, responds with hello world, and the number of times that person has viewed that page or made that request. And our repository just looks like this. Really, the things we're mostly interested in is the Dockerfile and index.js, but we will kind of talk about the Docker Compose file later in the talk. Oh, and real quick, these are just all Node.js stuff, and we'll get to the migrations a little bit too. That's another discussion. Our application code. Everybody can see this, right? Again, stupidly simple. We bring in the HTTP Node.js library. We bring in Express to make this a little shorter because I have to fit it on a slide. And then if someone does a GET request for the / path, we have an increment count function that we pass the remote address to, and then it returns a result. And really, the value is just the number of times that they visited the page, and we return all of that with the number of times they visited the page. We have a little bit of error handling, and then we bind to 8080. And keep that in mind, because 8080 is important. And the Dockerfile, I have to admit, when I started digging into Docker myself and started looking into how to make images and how to run containers, I expected this to be much more complicated. This is super simple. We're grabbing a Node.js image from Docker Hub. We're grabbing, it's the 10.x. You could ask for 10. Something else and be more specific about the image version you're getting. But in this case, we're going to grab 10. Whatever, because I'm not too super picky about the subversion. We're going to say the working directory is /app. That's where kind of when Docker runs all these instructions down this list, it's going to run most of these ladder instructions inside of that app directory. And then we're going to take the current directory we're in on the host OS, like where we're running these build instructions from, and we're going to add that all to the app directory. And then as the container is building, I'm going to run npm install, which will, if we take a quick look here, it'll just install all the packages defined in package.json and whatever's in the lock file. And then we're going to say, hey, this container is exposing something on 8080. And we define an environment variable, which just kind of gives a name to the service. And then we call Node and tell it to use the Node.js file that we saw a moment ago. So, a quick aside, this Node.js 10 image, that's coming from Docker Hub. And Docker Hub is a giant image repository that Docker maintains that's public facing. And most services that we all use daily is available there. You can get Postgres. I'm pretty sure you can get RabbitMQ. MySQL, I'm pretty sure is on there. Kind of all the real popular services are there. And you don't even have to define a file like this to get them. You can, in a moment, and I'll show you the Docker run command, you can just run that with pretty much any image name or a tag that is out on Docker Hub, and it'll just pull it down and run that service for you. Question?
So if you're on Mac OS, you're running the Mac OS version of Node. If you're on Windows, you're running the Windows version of Node. Same Node is going to get a OS-specific version?
So no, on all three environments, you're going to be running the Linux version of Node. Because if you're on like Ubuntu or Debian, your Docker engine is running straight on top of your local kernel. If you're on Windows or Mac, there's a virtual machine running, I think it's a Debian or Ubuntu, I can't remember which, running a Linux kernel and then running the engine on top of that. So it's always the Linux version you're getting, which in my opinion is preferable, because writing Node.js on Windows is awful. Question?
So is there a way to specify, like, so I know there was an issue in the last month where there was a malicious Docker image that had been become very popular, And so is there a way to like specify, hey, I only want to have like signed images or something?
That is a really good question that I do not know the answer to.
Okay.
Um, I would hope so, but my gut tells me probably not. They're probably, I mean, I don't know this for sure, and I could be totally off base, and maybe the Docker engineers are better than the NPM engineers, and maybe they have code signing like they're supposed to, but I don't know. That's a good question, and that's something that like at least someone at your organization should know and be aware of. In fact, when I get home, I'm going to look that up, because that's something that I need to know. Anyone have another question? I thought I saw a hand for a second. Nope. Okay.
Is it more common to use an image from Dockerfile versus create one from scratch?
It depends. So if you're using like if you're running Postgres or MySQL or something, you can build your own. It's just a lot more work than I think it's worth. Now, if you are, let's say you're concerned about code signing and you're concerned about a malicious image, you can totally go and like check it out with apt-get, and you can roll your own. You can even, in a lot of cases, go to GitHub and download the actual files that they were built from. And those may even include like an apt-get install call inside of them to install that service. So if you're worried about it, you can kind of go down a layer and roll your own images. And I'll get into running a private image repository. Well, I won't really get into it. You can run your own Docker image repository. A lot of organizations do, especially because like you can't really push your company's applications out to Docker Hub, right? Like you don't want to do that. You want to run that like only in-house. So you can totally run a Docker repository, or Docker image repository. AWS even just provides you one. Like if you use the AWS Elastic Container Service, you can just go like you can just go and create a repo, and I think it like only costs you S3 money for like the image sizes, but I'd have to double check that. And you can just upload and push them up, and then anybody that happens to have credentials in AWS can pull them down. Or you can run them out inside of the, out on like ECS or some other AWS service. In this talk, we're going to be building an image real quick for our front end application. We're not going to publish it, but if you wanted to, you could create an account on Docker Hub and push it right up. And if you're a company that is like, like you're Postgres or Mongo or somebody, and you want people to use your service, that's something you should probably do. Like you should probably make it as easy as possible for people to use your service in their environments. So building and running. Building the image, super straightforward. You just call docker build -t is the tag. It's kind of like a name. And then the period is pretty much just saying use the Dockerfile in the repo that we're currently in, our current working directory. And it'll just run through the steps that we just saw, step 1 through 7 there. And then it'll build successfully, and we'll see that it'll tag with the latest. I think you can tag a particular version if you want. I didn't think it was worth it in this talk. But you can like publish multiple versions of your container. We'll see that in a little bit when we start using Postgres. Any questions with this? Does all make sense? And then running the image, if we want to run it in the foreground, so it just kind of like that's our running process in our terminal, we can just do docker run and then the name of the image. In our case, we built one locally named front end, and it just runs it, and we can see the standard output. If we want to run it in the background, same command, just with a -d for detach, and that will place the process in the background. If you want to, question. No, you're fine. Go for it.
If you want to hit the file system and manipulate anything, does that require more hoops to jump through?
So when you say hit the file system, like what is accessing the file system? What process? Like your application?
Yeah, let's say your application is going to generate some sort of image that it stores. I don't know how to read
So,
it without
inside of the container, you pretty much have like a full jailed environment that you can do whatever you want in. And in fact, I believe, if I remember correctly, your application's process is running as root. So you have full run of the container. You can do all sorts of really dumb stuff, and you can totally screw the container up. But you just run remove, like Docker stop and then Docker remove, and you just remake the container after you fix whatever, stupid mistake you made or, stupid experiment you were doing. And so it's a fairly jailed environment. You really, unless you find a security vulnerability that breaks the jail and breaks out into your host operating system, you're not going to have any problems. You just delete it and try again.
When we're talking about like setup of how does it work? Do you have how does it know how big your container can be?
That's more disk limitations, which I have hit on my workstation at work. I have to allocate half of my disk to Docker. And I still occasionally have to like shut everything down and prune it and wipe it out and rebuild all the containers.
Does Docker like work with ZFS or Btrfs with disk quotas? Because like I know both those file systems you can set like per directory quotas, and I know like LXD will use those quotas to limit the size of images. Does Docker do the same thing?
As with most of the questions you've asked, I don't know. You're getting lower level than I'm getting. If I was running Docker in some kind of production environment where I was running like production servers and running Docker Swarm or whatever, I would definitely want to know the answer to that. I don't think Docker imposes quotas, but I could be wrong. I think it would be more of a case of your host operating system is going to apply whatever quotas you put in place, but I could be totally wrong. Docker may be sophisticated and allow like inter-engine quote or container level quotas. I don't know. Any other questions? Did I get David? Did I get your? You think so? Okay, you can always talk to me after, or email me or whatever. That is a good question. The answer to that is yes. So we're not gonna, it's a good question. We're not gonna touch on it as we set this application up, but you can define volumes inside of, I believe, your Dockerfile as well as Docker Compose. And those volumes will persist. So you can just kill that container, recreate the container, I think with the same name. I'm trying to remember how it knows exactly which volumes to mount again. But like the database containers usually do this so that if you stop your database container and you start it again, it's not a fresh database. If you want a fresh database, you have to kind of like stop your container, remove the container, and then go find the volume and run like Docker volume, I think RM and the volume ID, and then that will remove the volume, and when you start your container again, you'll have a fresh volume. Okay, yeah, thank you, John. I mean, yeah, it sounds like you can probably move the files around. In fact, I know you can because I think I had to do that at one point. You can, so one thing we're not gonna cover in these slides is there's a cool command called docker inspect that will just return a massive JSON object. And it'll tell you every little bit, like all the volumes, all your network stack, every little configuration bit that you might wanna know about a running container. And in there will be the paths on the host file system to the volumes. In fact, I needed to do that for some reason and I can't remember why. I think it was because I needed to find it and I can't remember. So if you wanna run it in the background, you can add the -D and then you can run docker ps and that will give you a list of all of your containers running or not. I trimmed the output a little bit so to just show our front end, or the container made from our front end image. We saw that it started like 2 seconds ago. I was pretty quick with the commands. And that it's been up for a second. And then the port that we exposed, and then a funny name. Every container you make, if you don't give it a name, you will get a funny name. That is the least funny name that you will see tonight. Okay, so our container's running. We should be able to access it, right? We should be able to do a curl request against localhost 8080, and we should be able to get that nice little hello world with our view counter. Not quite. And this is what like tripped me up like a year ago or two when I was looking at Docker initially, and I was like, oh, this sucks. Why am I using this tool? So this is what trips new users up. Everybody has to deal with it. it's just a fact of life, and there's good reasons for it. What happens is that 8080 is exposed on the container, and it's available inside of the private Docker network. So if you were to spin up another container and you were to use that funny name we saw earlier as a host name, that container could talk to 8080 just fine. But outside on the host operating system, we can't. 8080 on our host OS is not mapped to 8080 on this particular container in the private Docker network. So what we have to do is stop the container, remove the container. Got a little like one line there for that, and then rerun it with a -p, and then we just say, hey, map 8080 on our local operating system, or on our host operating system, to 8080 on the front end container, or on this new container, and we let it run, and we can run Docker PS again, and we can see that, hey, it started again. I was a little slower on the PS line this time. And we can see that it's mapping 8080 on all of our host interfaces to 8080 on this new funny named container. And then we can try to run curl again, but we need a database. So, we're gonna get to that next. A quick aside, yeah.
Can you go to the previous slide? I want to see what the ports list, the previous one was at. What did it say for ports before?
There was no mapping.
Okay, so did you repeat the question for people?
So I don't know your name. I'm sorry. If we've met, I apologize. Bryce. Hear people chuckling. So what he asked, he wanted to know, what this port section looked like. And the key difference is in here, it's just exposing this to the local Docker network. In the next line, we see that this is a shorthand for all interfaces, 8080. And then we see that it maps to 8080 on the TCP as the TCP protocol. Any more questions? No? Okay, so now let's say we have containers running and we just want to look at what's going on with the container. We want to see standard out or standard error. We can run Docker logs and the funny name for the container, or a reasonable name if you give it one. And it'll just print out standard out and standard error for you. There's some nice switches where if you want to follow it, like if you're running the tail command, you can follow it rather than just seeing the last however many lines, or I think it's all the lines. If you only want to see the last like 20 lines or whatever, you can do tail here and say 20 lines. So the error we got was that there wasn't a database, just to remind us. Error accessing database, and that's what we told it to output if there was an error when we tried to access it, when we tried to do our increment count function. Okay, so we need to bring up a database. To do that, we could run apt-get, we could run homebrew, we could run whatever tool Microsoft provides.
They don't provide any.
That's the joke. Yeah. Thank you. Thank you for spelling it out for the home viewers. Microsoft doesn't provide a command line tool to install things. I don't know why. It's 2018. And this has been a thing for like well over 20 years now. So they hate open source, no matter what they tell you. So you can ask people that were open source 20 years ago. Yes, so we can use apt-get, homebrew, whatever, to install Postgres. We can then, connect to it with the root default password. We can create a user if we're doing things right. We can create, a new database schema if we're doing things right. Make sure it's only writable and readable by that new user that's not root, or Postgres in Postgres's case. And then we can make that schema, we can run our migrations, and now we have our database, and we can reference it with an environment variable when we start our front-end container up. But this is a Docker presentation, and as much as I like pasting funny things like that into READMEs and then making poor new hires go through a giant-ass README and make them hate life and go get a beer during their lunch, we can kind of do better than that. And we're going to do it with Docker because this is a Docker presentation. So we can use Docker Compose and this is one of my favorite tools in the Docker ecosystem. We can define a YAML file and define all the services in our environment, feed it those same parameters that we're feeding into Docker run, and we can have one-liners to like start multiple services, to stop all the services, to pull new images and build all all the code in whatever repositories are referenced by Docker Compose or whatever. And it just greatly simplifies management. I like Docker. I would use Docker even if Docker Compose didn't exist, and I would give those poor new hires and those poor teammates of mine that giant ass README with all the lines to run. Maybe one of them would make a script out of it. That person would get a promotion. But I would let someone take initiative on that. But we can use this YAML file, and it's just so much easier. So we can start our database service, our migration service, our front-end service, and they get reasonable names that aren't funny, unless we make them funny. But that's our job, not Docker's. So we can run Docker Compose up -d, run those all in the background. We can stop them all. You might notice that migrations isn't there, and that's because migrations is a short-lived container. As soon as the migrations run, it just stops. So it's already stopped. And then if we want to update, we can just run Docker pull. And any new images that are like meet the tags that we have, it'll just pull those images down, and then we can run Docker Compose up again and start them all again. And the Docker Compose file is pretty simple. It has a version in it, and this version maps onto some minimum Docker, engine version that you have to have. Don't worry about it too much. Whatever you find on Stack Overflow, you can probably just copy it. And then we define a collection of services, and in our case, we have a DB service, a migrations service, and our front-end service. And I'm trimming this, of course, because this all wouldn't fit on one slide, because slides have to be small, and you guys have to be able to read it in the back. So that one section that I trimmed, this is what the DB service looks like. We say, hey, use the Postgres 9.6 image. It should always restart when it exits. There are other options there. You can have it only restart when it errors. You can have it never restart. There's a few options there. We map the same ports we did with that run command we talked about earlier. And then we define the same environment variables that we talked about in that Docker run. And this is where kind of like taking all of those little details and putting them in a managed file is what makes everyone's life easier. The migration service, which I'm not going to talk about too much, the context is that migrations directory that I kind of glossed over when I showed the directory earlier. In that directory is the migration service, and it has its own Dockerfile. And so this kind of definition here is basically saying when we spin up a new migration, when we build and up our migration service, just build a new image from that migrations directory, and then we pass it in a database URL so that it can connect to our local database with the same details we fed this previous one. So password, front end, whatever, same thing. We feed that to the migration service so that it can connect and run the migrations. And then our front-end service is a little bit similar. We say it's building from the local the current working directory and that current Docker file I showed you many slides back. Using the depends on, you can define the order that some of these containers are started in. In this case, it waits for the DB container to start, then it waits for the migration container to start. And then we map the same ports. We tell it to always restart when it exits, and we feed it the same database URL. And if we want to run all these in the foreground, it's just Docker Compose up build. I trimmed a lot of the output, but it basically runs the image build process for our front end and our migrations and pulls down the Postgres image and starts that container. And then we can see that it is following that depends order that we defined. Just a quick point. This just says depend on DB. So we get the DB first, we get migrations second, we get front end last, and then we get an aggregated standard out and standard error output for this. And this will just kind of run and just flow on your screen. And if we want to run it in the background, It's the same as Docker, just the plain Docker command. We just add a -d. And now it runs in the background, and we can run docker compose ps, just like if we were using the vanilla Docker command. And we get a slightly different output that tells us what's up and what's down, and it will even output if it's already stopped, which we can see the migrations container already exited successfully. Any questions? This all makes sense? And if we want to update our containers, let's say Postgres releases 9.6 dot whatever, or someone on your team or someone on the migrations team makes a modification and you're between tasks. Like you're like, I'm done with my current task. I've moved stuff around in Jira or whatever task tracking tool we all struggle with. We can go, great, I'm between tasks. I'm gonna do a quick poll, make sure that I have everything else the company's pushed recently, and run up again with --build so that it just intentionally rebuilds everything. And we're back where we started. We have a running, functioning development environment that we can do development on.
Are you running git pull inside of the container, or is this?
Sharp eye. So, the question was if I was running git pull inside of the container. The answer is no. I revised this slide, and in an earlier version, I talked about checking that Docker compose YAML file into a repo, and you caught me. I didn't update this slide. And so now, the thing that I didn't talk about, I'm going to talk about. So, we're pretty much done. That's like Docker in a nutshell. If you want to pull images and run images, and you want to use Docker Compose to manage your environment, you kind of all know the basics. Like you can all kind of copy and paste your way, or go read the docs like you're supposed to, but we don't always do. And make a Docker file from scratch. You can make the Docker Compose file from scratch. You can run these lines, whatever. Here I have some helpful tips to make life easier for you and your team. In your organization, I would use a private image repository. It's a really good idea. AWS isn't the only option. There's quite a few options. Some that don't require that you give all your developers AWS credentials, which sometimes isn't the best idea. So your organization can run a private image repository, and you can have your build server, anytime someone pushes code into master, they can go, great, cool, build a new image and push it out to the private repo. And then you can make a Docker Compose file that doesn't have any build steps. All it does is point to the most recent image out for that service in your private repository. And then when you want to set your development environment up, you just go, great, check out that environment repo, do a pull, that git pull that I didn't trim, and then just run Docker Compose up. And it will pull everything, and it will start everything, and you now have a functioning environment that you should be able to go to 80/80 on and use your application. If you want to work on a service, you can check out that service's repo. You can stop and remove the container in that Docker Compose or that Docker environment. And if you put a Docker Compose file in your services repo, that tells it to use the same network name that you put into, and this is a little detail I left off. Docker will you can make multiple networks and have different Docker Compose files, join, fire up, and all the containers join different private Docker networks. If your service repo will join the same private Docker network, it's just another container in that network, and you can sit and iterate on it and iterate outside of that environment repo, and when you're done, do your PR, let it get merged, and then just repull and restart the Docker Compose in that environment repo, and now you have an up-to-date environment. And if your other teams are doing all of that, all you do is git pull and Docker Compose up, between tasks, and you're kept reasonably in sync with everyone else in your company. And depending on how far you let production get behind bleeding edge, you'll be reasonably close to production. You can even take it a step further and only check out stuff that has been released to production, so you can have like a production environment versus a bleeding edge test environment. That can be just two different repos. It could be two YAML files inside of the same repo, and you just say Docker Compose, use the one versus the other. And then another cool thing that some people will do is you can mount a directory on your local file system from the container. And then you can kind of set your application, your container, the application your container is running to hot reload anytime something in that directory or subdirectory changes. So you can just sit there and iterate in that service repo and have the container, your service repo started, just restart every time you have a change. And once you're done, you can, do your PR. What's up?
With that sort of practice, you can run into some like iNotify watch stuff that doesn't tend. When I've done that in the past, it didn't work out very well.
It's slow.
Yeah, it's very slow.
I will.
It's a reload. It's like you might as well just reload on your desktop.
Yeah, it works. Where I work, we do that in some of the Go services that we have, and in some of the Node.js services. It's not perfect. I have had to like a few times go, why didn't that run? That's kind of weird, and had to like make a minor file change and save it just to kick it. Is it faster than running the build and completely like reloading the container and rebuilding from scratch?
Probably not.
Yeah, I mean it can vary. I think that might vary from machine by machine and OS by OS.
I think what I usually would do is like for that particular file, since it's going to build like JavaScript or something, or maybe Go, it's going to basically build the same file. It works better with JavaScript because then you can just build it on your OS and intercept that one request that goes to the container on your host and have it go to your own like host layer just for that one file.
Okay.
So you sort of like proxy it out so that it doesn't go to the container. That's what I would do to get around.
Okay.
To get around this. Yeah,
But that's like a side process you're running that's like doing that for you.
There's an operating system proxy that would kind of catch
Yeah.
web requests, look for the specific bundle file, and then just grab it from OS.
And I think that would work for like React code or code that's running in the browser that's not compiled. So if you're running compiled, you're just gonna have to rebuild, whether it's a hot reload or whether you stop the service and start it again. And excellent point about just IO. The IO notify stuff is slow.
Yeah, to get into these things, you should learn about iNotify.
When I was talking about giving this presentation, a friend of, I think, a mutual friend of Aaron and I's brought that exact point up. Like, it's one of those pain points that everybody kind of hits and you just have to live with.
You'll spend all day with weird bugs. That's like one command setting your iNotify watch capital fix.
Yeah. So again, the hot reload stuff is nice. As Garrett's pointing out, it doesn't work perfectly. So if it's not working, maybe just don't use it. I've seen it work okay. I've seen it take 10 seconds or 30 seconds to trigger and reload. And that's about it. So what's next? For all the people that haven't used Docker and don't use it in their environment and isn't using some container service already, you should really start using it. It will save you a ton of time. Garrett.
I think this is a perfect time to mention, I guess probably tell you about since you haven't mentioned it yourself. Have you heard of something called Container before?
I have not.
Okay, so I highly recommend Container.
It's Container?
Portainer, like port.
Portainer.
Portainer, like container, but with port. I mean, it fits the narrative, right?
Yeah.
So anyway, Portainer is really cool. You just you can get it as an image from DockerHub. So it's easy. You just pull it from DockerHub, run it, and then what it ends up doing is it's a web interface that runs on your local machine. You can run it anywhere. I run on my local machine, and it will give you a web interface to everything Docker does.
Okay.
So you can view all your running containers. You can view stacks like from Docker Compose, and then it makes certain operations that actually are more of a pain to do through the command line, because the container is immutable. There's the kind of hassle. If you want to change a port mapping, you have to destroy the container and recreate it. But if you have lots and lots and lots of things attached to it, like different drives and different other things, it's just kind of it can be scary to make sure you get everything migrated to the next container.
Yeah.
System. You just go and edit a box and hit save, and it does that whole
Okay.
process for you. So there's I'm not really a fan of using a GUI over the command line, but it actually saves people that would really like command line, I think, a lot of hassle. And then it also will teach you about Docker.
Okay.
Visual perspective. It's really nice.
So for the people at home, there's a management interface that Garrett's mentioning that's called Portainer that is available on Docker Hub that will give you a web-based management UI with some kind of additional tour stuff, it sounds like. It'll kind of teach you a little bit about Docker.
I mean, I would just say it lays it all out, right?
It lays it all out,
It's
okay.
a website, so you don't have to read through man pages or
But I like reading through man pages.
certainly lots of More power to you. But a lot of people, there's like just features I didn't know about, and I'm just seeing like, oh, you can do this, and it's like I just wouldn't have known.
Yeah, that's a good point. And I actually, as much as I love reading man pages, I kind of do and kind of don't. Good man pages, yeah, exactly. The ones that put the good stuff near the top that everybody uses, not the ones that bury it alphabetic. Well,
Or just,
yeah.
just don't have it.
Or just don't have, yeah.
I make that point really just because it's really confusing when you first try to use Docker, what all the different terms mean, and so it can really help you sort that out. I don't learn really that much from it, but it definitely,
Yeah.
like I said, for me, if I'm wanting to change just a port, but it requires me to do like 5 steps that I could screw up in my terminal.
Well, hopefully Docker Compose would have that all for you.
Like just one, little thing.
Oh, okay.
Grab a Docker Hub image or something, and I just want to move it.
Okay.
Like or move a port around on it or something.
No, I agree. And like when you're running one container, it's remembering all the command line switches is a pain, especially when you type history and you forgot to set your history to be like a million lines, and it scrolled off. Like that sucks. Again, that was port container and it port-tainer.
Yeah, it's like basically 2 commands and you have it up and running.
Okay.
It's really easy and it's really awesome.
And you could even put it in your Docker Compose file and just bake it in your environment. Yeah. Again, I'm going to say Docker Compose because I love that tool. So again, install Docker. Hopefully this presentation's given you enough that when you start trying to containerize some of your applications or containerize your environment, you're not like, oh my God, what do I do? You might at least know what to Google, right? Like Google some of these keywords. Again, use it. It's super useful if you're not already using some other container solution that works just as well. The docs are super good. Most of everything I read, I just read through the docs. It took me, when I hadn't used Docker very much before working at Envision, in like the first couple days, I just sat there for a good 30, 40 minutes and just started reading down through the docs, and they're super well written. In fact, these slides almost follow the exact sequence that they introduce, because they just did a really good job. And that's it. Any questions?
What other container solutions are there?
Oh, there's like Kubernetes and this guy here that like knows way more about containers than I do could probably list a bunch. There's a few. Kubernetes, I think Vagrant's not quite a container solution, but it, or CoreOS, yeah.
Well, Rocket.
Rocket and yeah.
So they were saying Rocket.
Like Proxmox, which is like what this gentleman was talking about sort of earlier, which is like LXC type
Well,
stuff, but
yes,
very similar.
you have LXC, and then on top of LXC you have LXD. LXC is the container library. LXD is the container hypervisor.
Okay. So LXC, Rocket, CoreOS. There was
In there, I would recommend this really cool is Proxmox, which
Proxmox.
has to do with a lot of the stuff you just mentioned.
I'm just making sure I say these so the people at home can hear this and Google and read about these things. Any other questions?
Yeah, you were talking about ECS on Amazon, the Elastic Container Service,
Yes.
which is basically Docker on AWS.
Not quite. I think so. The question is, he's asking about Amazon Elastic Container Service, and you mentioned it's like Docker, but on AWS. As I understand it, Docker, or AWS, actually offers a service that is literally the Docker engine on AWS, and that's not what Elastic Container Service is. Elastic Container Service will use a Docker image, but it won't really pay too much attention to like the contents of the Dockerfile. You actually have to kind of redefine much of that, like what the entry point is when defining ECS. They call them, what do they call them? Tasks. And then you group them with services. Oh, a quick aside. So I know this is on the top of my head because I set up a Starbound server this weekend using a container from Docker Hub and hosted it on AWS ECS. It took me a couple hours to like work through, not using ECS before, but building an image locally, throwing it up on the AWS container repo, or image repo, not container. Getting that it all worked really well. I had little issues with it, and ECS works really well. But as there's sirens. I'm pretty sure there's a separate service now that is like running Docker's Swarm, I think. Can anybody corroborate that? Like it's a recent thing in the last month, I thought.
To deploy containers as a swarm.
Like yeah, on AWS, and it's like running Docker Swarm like almost vanilla on AWS. Was there more to that question?
Yeah, I was wondering, you were talking that you played with it, and because AWS has its own pain points, and like Docker or containers in general have its own pain points. So like the two together, is it like super painful?
So the pain points that I experienced on it were I had to tell AWS to set up a Docker image repo, or I had to like go in and tell it that. There were a handful of steps where you have to tag your the container you've made, so that when you push it to AWS, it knows what to do with it. So there's like about 5 lines you have to run to kind of prep that local container for pushing it up to AWS. Once you run those lines and you do the push, then you have to go into the container service and you have to define, I believe it's like a cluster. It's something like that. There's like you have to define a cluster, I believe. You have to define a service, and then you have to define tasks. And the tasks end up being like an instance of that image that you pushed. And it took me probably about 3 hours, like Googling and like getting through it. Now that I've done it once, I could do it in about 10, 15 minutes. I'd probably still cuss a few times, but like I'd still get it. It would be much faster now that I'm aware of these little idiosyncrasies and just how much I have to kind of define for ECS, that if they would just read the Dockerfile, even though I don't know if that's in the image or not, it probably is. If they would just read the Dockerfile, they could answer some of those questions for me, but like they didn't. And
And I guess my last question on this would be, have you tried like continuous integration like Jenkins with it?
I haven't. But let's say like we're doing a Jenkins configuration. All those lines that I'm running locally, I would just drop into like a Jenkins build step. And I'm sure there's even like Jenkins plugins that would do most of this for me, where I provided the AWS credentials and a little bit of the details about where it's going in AWS, and it could probably manage that all for me. That'd be my hunch, because that's my experience with Jenkins, is there's always a plugin for just about everything.
Yeah, it can definitely do that.
Yeah.
It can like take a container, spin it up, deploy it, or just do it for testing purposes, whatever.
And that's some of the stuff that we're doing.
It actually makes it really nice.
Yeah.
Because it's fast and it's accurate.
And that's some of the stuff that like we're doing at the company I work for. We'll use some tools where if we want to test an environment, we can just go, hey, spin the environment up, run all of our actual integration tests that talk across services. We'll still have to like stub stuff in for Amazon, because we don't want to talk into Amazon directly, things like that. But for the most part, we can get pretty good multi-service or cross-service integration tests going.
So how does the Docker engine work across servers? Does it will like or
So that's Docker Swarm,
that's Docker Swarm? Okay.
and right? Yeah.
Swarm will manage a bunch of containers. And Swarm itself is a container, but that'll act like your gateway. It's a lot like
It's more like Kubernetes, I thought.
Kubernetes does the same thing. I don't know what they call their manager container, the one that rules them all and spins them up or puts them down, whatever you need to scale, all that stuff.
I think they call them pods.
That is a swarm.
Okay. Yeah, and so So did that answer your question, or am I?
The answer is Docker Swarm. If you have Docker instances spread across servers, you use Docker Swarm.
Yes, Docker Swarm would be the orchestration service that would go and manage all the engines and make sure that you're running however many instances of each,
I'm just really interested about the networking. Like, so if I have multiple Docker engines across servers, like, do the engines, how do they talk to each other?
You're deeper than I've gone.
Okay.
Sorry, that's like I'm just gonna have to like make a little sign that anytime you raise your hand, I just be like, I'm sorry, I'll have to Google that and get back to you.
Swarm doesn't care where they are. You just have to tell them where they are.
So Swarm will like join the networks essentially and allow.
Do that, but it is that container that you need to give all the creds and everything to find it. Whether it's its own network or the network spread across things, it doesn't even care.
Okay. So the answer is Docker Swarm.
The answer is Docker Swarm. Yeah.
Yeah. Okay, that answered your question, right? Any more questions? Okay, so now for the last slide. Thank you for showing up. If we knew what presentation was next, that would have been on the bottom. Thankfully, I remembered the to be announced tag that I put down. I remembered to remove that. But, okay, thank you.
So yeah, thanks again everybody for coming. The next meetup will be announced on meetup.com, where this one was announced. So check it out there once I get the description and everything nailed down. Again, thank you, Ryan. Great presentation. I learned a few things about Docker, and I've used it lots of times. So yeah, feel free to hang out and pester Ryan with questions. He loves that, especially the more technical ones where he has to say he doesn't know. Those are generally his favorite. But yeah, feel free to have more soda or beers or whatever else, and I'll see you guys all next time.